we talked about. The first case was hinged, then fixed free, then fixed hinged, then fixed fixed. So in the first case, the effective length is equal to L. The second has effective length equal to 2L. Third case has effective length equal to 0.7L, and fourth case has effective length equal to 0.5L. So here, I really want to emphasize, in an exam setting, my suggestion is use the formula P critical is equal to pi square. What is this? Pi square EI over LE square. Pi square EI over LE. Yeah, okay, sorry, I stopped for a second. P critical is equal to pi square EI over LE square. Write this formula and then select whether it is LE equal to L, LE equal to 2L, LE equal to 0.7L, and LE equal to 0.5L. So these are the four cases we talked about. Just so Tom Vash can also join us, because I told him this is a buckling topic that we started, and there are the four cases that we studied last time. Now, on that note, what I will do is I will go back, and before I, we have a student who is writing. Can you please take a picture, because I did show this last time. Okay, so on that note, let me go back, and before I start any examples, let me go over something exceptionally important. That is the concept of critical compressive, critical compressive stress. Now, there are students who are saying, what do you actually mean by this? Why have you written this? Let me go over this very quickly. You have this object, and then just tell me whether this will buckle or not. I just want you to intuitively answer, and then I will start some examples. But I think we have to cover some important concepts. Otherwise, this is very confusing. So just tell me whether this object that I have created, will it buckle or will it get crushed using by yield stress? So if the yield stress is equal to P by A, and someone on this planet Earth is applying a load of P, will it buckle? Will it fail under buckle or not? You don't think so, right? Same here. I doubt that it will buckle. I think it will get crushed. But right now it's just thinking, right? Okay, just tell me whether this will buckle. Buckle is a word that you do recognize, right? Buckle, like if I apply a load and something goes like tin, this is what is known as buckling. Okay. Now, why don't you tell me whether this half a millimeter dia rod, will it buckle or will it yield? I think it will buckle, right? Again, all of us are using the word think, which we don't like, but I think it will buckle. It will fail under buckle. So which one will yield first and which one will buckle first? Which?
The thin one will buckle first.
Yes, nice. Which one will fail under yielding? Which one will yield first? And which one will fail? And which one will fail? Which one will fail? Oh, come on. Which one will fail? In last final exam, I gave one problem from this, by the way. Which one will fail by buckling? So I think our class has already answered that the second case appears to be failing under buckling if it has to fail. The biggest question is, how on earth can you decide, right? So I will write different formulas. What was the formula? P critical is equal to pi square, yes, EI over, yeah, it was effective length, right? Okay. Then what was the effective length? There were four cases: fixed, free, fixed, hinge, and whatever. I forgot already. Yeah. Yes. So right now, I'm not going to get into that. I just want to talk about something different. Pi square E. Anyone who remembers the formula for moment of inertia, area moment of inertia? Not
C over I.
huh?
No, area moment of inertia.
Hmm.
Yeah, and no.
Nahin. BH cube by 12 is for rectangle. Can you give me any general formula for moment of inertia? Any general formula? Like one formula that can be the answer to everything. So go back to dynamics. In dynamics, did we talk about I is equal to m multiplied by k square, and k was radius of gyration, a hypothetical construct. If I gave you the value of k for, let's say, this circular cylinder or any object for that matter, you can get mk square. For area moment of inertia, it is ar square. Okay, so please bear with me. A r square. What is r? Radius of gyration, not radius. Radius of gyration. Am I clear on this? Okay. So if I write I is equal to ar square, where r is the, you have to bear with me. Trust me, the questions will be super easy and interesting if you understand this. Radius of gyration. Okay. Now go step by step with me. What is LE? It is effective length. All of you told me. EF, effective length. Hi. You are Tehshin Chan, right? For the last two classes, half the class I have asked, are you Tehshin Chan? Finally, Tehshin Chan arrives. Okay, you are Tehshin Chan. I was like, who is Tehshin Chan? Okay. R is the radius of gyration. You have already told me. What is LE over R? This is known as, what is known as SLENDERNESS, slenderness ratio. You have to Google this in a Oxford dictionary to see the English. Cylinder. If I think we say someone is slender, so probably, let's say hypothetically, I am tall and I am thin, right? So that means I am slender. I think I'm saying the right English, but you have to Google it. This means it's the slenderness ratio that will determine which one will yield first and which one will fail under buckling first. In the left case, you have this big dia, right? Big radius for the left one, and its height is very small. In the right one, the dia is only 0.5 millimeter, but it's very big, 1 meter. So your LE over R for that fellow is very, very less, and LE over R for this one is big. So this means if you have a huge LE over R, the object, if it has to fail, it will fail under buckling. And if your LE over R is very, very less, correct me if I'm wrong, LE over R is very, very less, then if it has to fail, it will fail under yielding. Is this point clear?
Yes.
Huh? Now you have joined us, right, on this one? Okay. Now that you understand this, yes, Mehmet.
What does the yield mean?
Fail under yielding. Fail under yielding means that it will yield. It will not be an elastic object anymore. It will crush. It will not come back. It will yield. It will fail. It will get destroyed.
Is this ratio determined by experiments?
Yeah, we will see that. So technically, should I answer the question immediately? The answer is experiment means that I have to measure, let's say, the length of the rod, then I have to measure the geometric, let's say, dia or whatever, and I have to calculate the moment of inertia. So if I have all the dimensions for this one, the length of it, let's say this is a solid object, whatever, and I also have calculated the dia, you can call it experiment, then of course I will sit down and I will calculate I equal to.
No. I mean, like, okay, we get the slenderness ratio, we
Huh.
will get the value. There has to be a critical value which we say, okay, it's above this, it's compressed, it's ideal, it's below that, it's cycle. So that value.
Yeah,
it's
5 minutes. I need 5 minutes for that. I'm coming to that point. You have yes, you are hinting at the point where I will arrive in 5 minutes. That is the critical compressive stress.
Also, slenderness ratio, in slenderness ratio, the R is the radius of gyration.
Oh, absolutely. R is not the radius. I have emphasized critical compressive So I will answer Ahmed's question as well. Just you have to bear with me. Okay, sigma CR is the critical compressive stress. Okay, is everything clear on this slide so that I can answer his question? Everything is fine. Let me double check. I think everything is covered. Hang on for a second. Where did I even write this sigma CR? I'm sorry. P CR over A is equal to sigma CR, which is equal to pi square EI, but there is no I, right? Now I will do divide, then I will do bracket LE over R. Is this fine actually? Can you double check? Acha. So remember, sigma CR will is at least in right now, for example, hinting at the failure of this buckling formula, but we'll see in future what happens. Okay, now I will answer Ahmed's question. I will stop for Usman and everyone else to write. So now we will come at the real question. What exactly is the threshold value? And how do we measure it? Very nice.
Hocam, does the slenderness ratio change with respect to material?
Oh, no. Oh, yeah. So hang on. You mean that critical threshold value? So for example, if this is aluminum and this is also, you mean that? The answer is I will answer this with yes. Immediately I will answer. Actually, I also had to look at the plot to say a yes or no. Yes, but 3 minutes.
Material affecting critical stress value, but it doesn't affect the slenderness ratio, I think, because.
Okay. Now Ahmed's and Mehmet's both have the same question. So you know what? I have to make a plot, and the moment I make the plot, both of you will answer the question yourself. This is the okay, now my drawing comes into the picture. You can beautifully draw a line like this, and you will see me struggle here because I always do by this stupid pad. Come on. Okay, I think I did a decent job today. Yeah, okay. So I have ended up making this, and now I will answer both of your questions. The y-axis has sigma CR, the x-axis has LE over R. And in case you are getting confused, I actually write this formula, sigma CR is equal to pi square E over LE over R square on MATLAB or whatever. And I started making this plot. And this is my observation. At this point, something strange happened. This is what is known as, not something strange happened, I'm sorry. This is the yield stress point. And this point, interestingly, touches the proportional limit point. And then I started making these dash line, and I started noting down the LE over R. Just hang in there with me. Trust me, it's not as difficult as right now it might seem to you. This is 50. Let's say, imagine it. This is 100. This is 150. This is 150, 200. Now, what exactly was this plot made for? Here comes the answer of first Ahmed. The elastic modulus I took as 2 into 10 power 5 when I used MATLAB, let's say. And honestly, I'm not even sure what this material is. You have to Google it. This value is 250 megapascals. Why don't you Google the yield stress of aluminium? So I once and for all tell you whether this is aluminium or steel. I'm just getting confused. And proportional limit value is 210 megapascals. Boom. Now I answered your questions. I hope I did.
Aluminium yield stress is 276 megapascals.
Yeah, so I think this is aluminium. Good. Seems to be aluminium. Okay, so for aluminium, so now I answered your question. Your question was, would material affect the critical threshold of LE over R? The first answer is yes. I think your question was similar. But first I have to explain to you this plot. because it seems very confusing. What exactly do I even mean by that? So this is what I mean by that. You see, proportional limit or yield stress, whatever, you have to select one of them. And now I don't want to get into, should we select that or should we select this? I'm telling you, I'm selecting proportional limit in an exam setting. Let's say if I give you the yield stress, you can select that value. I take the proportional limit stress. You see, I see the LE over R value, and apparently the LE over R value comes close to 97 or 100. How do I do that? I will explain to you. But for now, just understand, as long as your LE over R for this aluminium is greater than 100, we are allowed to use the formula that I showed you, the buckling formula that I showed you in the last slide. Boom. If it has to fail, you know what? It might fail under buckling. But if the LE over R value comes less than, way less than 100, 60, 70, 75, it will fail. This aluminium fellow will fail under yielding. But if the LE over R is 95, 97, 98, in the vicinity of this critical value, then it will fail in a combination of buckling and yielding, and that is a little complex behavior, which I will see if I can cover or not. I will answer your question. In parallel, I will write. Yes, please. Well, in fact, I can stop.
In which part the yielding and buckling will be appeared?
Simultaneously?
Yeah.
In the vicinity of 100. In the vicinity of 100, all the way from 95 to from 96, 97 in that critical zone, or probably 2-3 values above, below, the combination will happen. But right now there are students who are getting confused. How are you even writing all of this stuff? So I don't want to confuse you guys. Let me go over the steps. What was the formula? Sigma critical is equal to pi square E over LE over R bracket square. So because you're like, come on, like you are throwing these numbers, tell us the process. Now I'm about to tell you the process. Do the number crunching. Number one, write LE over R to the left hand side. This is the step one. And trust me, you can consider this as an example. You will write the word LIMITING. If you want to use the word critical, I don't have any issues. But I will address this as limiting. This is equal to pi square E over sigma critical. Okay, what is the value of sigma critical? Oh, really? Sorry. Okay, what is the value of sigma critical? Very good question. What is the value of sigma critical? 210. Let's take it as 210 for now. So now the answer comes out to be, what is the value of E? It is 2 times 10 to the power 5. Just bear with me. Trust me, you will understand everything if you just hang in there with me. 2 into 10 to the power 5, what was that? Megapascals. Denominator also has megapascal. Okay, then I think I am allowed. So just tell me the LE over R. Moment of truth. Ghazal, you are with us, right? Sure. I can repeat this if you want.
96.9.
Acha. Okay. Thank you. 96.9. Ahmed told us the answer. I will write it down. Just let me be a little meticulous. Okay. He said 96.9. Let me take it as 97. This is how you see this line. Now this is what you will write in English. So write in English very quickly, and then we will start our first example of today's class. Write in English. 1 minute. Of course. LE over R. LE is the meter. Yeah. Write in English. We are allowed to use. There was a name, by the way. How can I forget? There was a guy who created this formula. Slenderness ratio is not the name of the person. There is a name for this formula. Okay. Interestingly, I also forgot. So what was the name, man? Anyways, we will write in English that P critical is equal to pi square pi square, where is it? P critical is equal to pi square EI over LE square. We are, right in English, we are allowed to use the, okay, I'm sorry, I forgot the name. So let me write down the, what was the P critical is equal to pi square EI.
E over.
नहीं.
Over R.
अच्छा, pi square, हाँ, pi square EI, नहीं, there is I as well. Pi square EI over, let's say, LE square, or you can change it to AR square. You can do it yourself, that's fine. We are only for, you have to hang in there with me, LE over R greater than, very, very greater than, or greater than 97. Is it clear? It's very easy. There is no complication. I will.
We will eliminate answer.
No.
I mean that taking the.
Oh, you mean if it comes out to be, let's say if my actual LE over R comes out to be 97, then there is a combination of both the phenomena. So I think I understand your question. I need to explain this. I forgot the marker.
Yeah.
Oh yeah, so thank you. So only if LE over R, put a bracket here, write actual ACTUAL is greater than 97. Let's not be too fancy. I will just remove this greater than, otherwise you are getting confused. So I think I have answered questions or not? No? Yes. Should I make the first example for the today's class, please?
So, for example, we have a slenderness ratio. And if we change into material, changing to material, does it affect the LU divided by R?
Critical.
Critical.
The limiting value does get affected. The actual value does not get affected. I is AR square. This is A, and can you double check now for me? Because I struggle with these.
A is not going to be there. The A. Area is not going to be.
Sure.
Oh, no, it's going to be the.
1 minute. Yeah, I think so. So take your time and then tell me, because now it's fine, right?
Yes, it's fine.
Okay. Now let me answer his question, because now everyone is getting confused. So there are two LE over R that you will find in exam. Number one is LE over R actual. That is so easy, right? I will tell you the length of the rod. Then I will tell you its dimensions. You will have to calculate the LE effective length by looking at those 4 cases. The R value you will calculate. Don't worry, I will teach you how. That will be the actual for this object. Okay. Then I will have given you the elastic modulus, the proportional limit, the yield stress. Then you will do that right hand side and give me the limiting value. So now you have limiting value, and then you have for this what is in your hand for that particular material, and then you will compare the two. If this actual fellow is greater than 97 for this particular elastic modulus, for this particular proportional limit, for this particular yield stress, then you are saying, yeah, great, I will be using the P critical is equal to pi square EA over LE over R square formula. If the object has to fail, it will fail under Buckland. If not, then if it's less than that, we will have to go for yield stress. That I will answer your question in 10 seconds. That brings me to the first example. I think you guys have sufficient background for it. Please.
So if it's lower than the actual.
No, hang on. The actual is lower than the limiting value. Limiting is the litmus test. Limiting is the threshold. I have to have a GPA of more than 2. So GPA of 2 is the limiting value.
Yeah. If the failing becomes as a yielding, we couldn't use this formula. Right?
If the actual value comes out to be 55, 60, then of course it's way less than 97 for this particular case. If the object has to fail, probably it will fail under yielding. But if the value comes out to be 94 or 95 or come on 93, although it's less than 97, but my intuition is that the object, if it has to fail, it will fail as a combination of yielding and buckling. So it will be failing under buckling, but it will be failing under crushing as well. Okay, gentlemen, please.
If you calculate the limited part, I will use the lower value of stresses. Only sigma proportional.
Got it. Honestly, I don't remember from the top of my head, but if I give you both yield and proportional limit, go for the proportional limit value. If I don't give you the proportional limit value in an exam, just yield stress value, then you are allowed to use the yield stress value in that sigma critical place. This was your question, right? Should I use proportional limit there or critical? Then use yield if I only give you yield. Don't worry, because practically proportional stress value and yield stress value are very close to each other, so it will not create a world of difference. Okay, this is the first question. I urge you to please focus, participate. Number one task is you will tell me out of the 4. So this is a complete example. This is where you can see you will be tested in your exam setting. So just first of all, you will tell me the 4 cases, which case it will belong. You will go step by step. Okay. Okay. So let me create the complete structure. Now I will create nice and beautiful. Okay, then I will create okay, no need to get confused on this part. I'm trying to create this fellow. You will understand what is this. It's in the last semester, I still remember there were a lot of students who actually confused here. Okay, this is P. Okay, the question says that if the cross-sectional area, so let me say I am showing you the cross-sectional area like this. How many students agree? Oh, come on. Come on, come on, come on. What happened? Okay. Then the length of this fellow is 4 meters. Bear with me, please. 4 meters is the total length. And the section AA, when I open it, this is what I see from the top. I have a, okay, I think we have a student who forgot to, okay, that's, okay, that's fine. Yeah, that's fine, that's fine. That's fine, it happens, we forgot. Okay, this is the cross section. Now again, there are students who are saying, wow, the cross section is so complicated. Well, I know it's complicated, it's I-beam. This is, yeah, but, oh, come on. You know, oh, finally. Okay, now let's go over it. This is my YY axis. Now it will become pretty complicated, but, and this is my XX, right? Okay. The first thing that I will have to ask you is if the area is, please bear with me, 9272 millimeter power 4, IXX is given to me.
John, I think the area needs to be millimeters.
Why? Power 2, I think. Yeah, it was just a typo. Okay. IXX is 9272. You have to use a calculator, by the way, because I don't have this value. Acha. RX is I forgot something. What did I forget? What did I forget? There is something I'm forgetting. Okay, anyways, we'll see what I forget. 180 power 2. Now what I want from all of you is to help me a little bit and give me the value of 9272 multiplied by 180 power 2. And there is a reason for it, because I am changing few stuff here. Appreciate it.
One 1668960.
166
1668960. Yeah.
Okay, so I will write m power 4, and of course, for reasons that I cannot explain right now, I will remove this.
180 is it the distance?
Hanji? Sorry?
The 180 millimeter. Yeah.
No, 4 meter. 4 meter is the length of the rod.
I'm talking about the cross section. The distance from X to the top part of the arc. Is it 180 millimeters?
Why does it even matter? No. The answer to your question is no, but I will explain further. No, 180 is something else. I will explain why.
Okay, this value is the multiplication of 180 and that's a, not 180 square.
Acha, 1 minute. AR square was the formula for moment of inertia, right? MR square, AR square. So do the area multiply by 180 square for me, please. That
okay, then the value become 341 to 800.
341.
No, 300.
Hang on with me, please. Hang on. 300.
4108.
Yeah.
Okay, thank you. So just to double check, this is AR square that you gave me. Yeah. Area multiplied by 180 square. Okay, thank you for the help. I appreciate it. Now I will write millimeter power 4. I'm actually doing it intentionally. Now IYY is equal to, thank God it's given to me already, 834 into 10 power 4 millimeter power 4. Just to be clear, 8, 3, 4, 5, 6. Okay. It's given in the question, of course. Done? Got it? Okay, done. Now on that note, let us start the question. I will explain his question as well. His question was, what is the meaning of 180? I will explain that. But the first thing that I want from you is, number one, amongst the 4 cases, which case does it belong to? So you have to be careful and take your time. I will show you. Okay, exactly right. Last semester, 70% of the class actually said what you just said. That's why I really want to emphasize on this point. Look at the 4 cases and tell me, which case does it feel? You said fixed free, right? Actually, it is fixed. It is confusing, but I will explain why. Look, you see, focus here. This is fixed free, and look at this. This is fixed. In buckling, it is very easy to get confused. You see, I put that little fellow, and my rod gets penetrated inside it. So technically, that end is actually fixed when it comes to the fact that that end can support, number one, moment. It can support even the reaction forces as well. So that is fixed. The fact that I am putting a load on it and it can actually move makes me confused, and I'm like, this is free. No, it's not free. So look at the case of fixed, and I will show you again. It is free to move for sure. If it is completely from here and here constrained, then how on earth my object will buckle? The fact that it is free to move, it will buckle, but it is not a free end. If I want to make it a free end, I really want to emphasize on it. This is the free end. Oh, come on. I hope the Control Z work. Come on. Got it?
Yeah.
1 minute. Control Z. This is free end. Ghazal, this is free end. Ghazal, it is clear. This is free end. And let me do a Control Z. Usman, and this is fixed end. I think he already answered it. Tehshin Chan agrees with us, right? Okay, so last semester, 70% of the class, 60%, although I did emphasize this, not that I did not. Okay, done. So let us write case 4 with me. Solution. Trust me, if you understand, this is a 5-minute job. Tobash, you agree with us, right? That
Yeah.
okay, yes, okay. Yes,
One is the L or L by 2.
No. Total length. Total length 4 meters is the total length. Why would I give you L by 2?
If I were to calculate the stress at the joints between that flat plate and the horizontal rod,
Between the flat plate and the horizontal rod,
that would be 3, right? 3.
if you have to calculate the stress, I will have to think about it. Can I take a few minutes to answer that? Okay, so let me just first of all, I will answer this. We will think about this. His question is good. But the reason I want to proceed is because I forgot that I did not give you the values. And I am scared that you will feel confused that without any values, how can we even start it? But I will answer your question. What happens to that point? Okay, we will think about it. 250 megapascals. So I am coming to 200 megapascals and stress Y is equal to. So this also answers Usman's question that if both the stresses are given, then what will we do in the exam? Now here comes the biggest question. Calculate Rx and give me the value of Ry. Okay. Radius direction, Rx and Ry, both of them. So use a calculator. Do this. I equal to AR square. Give me Rxx or Rx if you call it, and give me Ry. You have to use a calculator. Hanji, sorry.
What was the formula? MR square.
No, MR square used to be in dynamics. Here,
Did you say AR?
AR square. I is equal to AR square, where R is the radius of gyration. I equal to AR square. In dynamics, it was M K square, right? So radius of gyration is K or M, whatever.
180.
180, right? So it answers your question. What was 180, right? Actually, I had the radius of gyrations in my notes and I was asking you to help me. So Rx, Ghazal told us 180. Done? Ry, definitely I need from you. No idea.
It's almost 30.
30, good. Thank you. I appreciate it. Okay, now the biggest question all of you are having is, oh, come on. We haven't even started the question. What exactly is happening? Let me, Euler was the name of the guy. So I will write down the complete English. A steel column 4 meters long with both ends fixed is shown in the figure. What is the minimum length of the column? Come on, for the Euler's formula to be applicable. Euler's formula to be applicable. What is, Euler is the name of the guy. What is the minimum length? What is the minimum length of the rod? After this example, we can have a break. What is the minimum length of the rod for Euler formula to be applicable? This is the first question. The second question. Oh, come on. What is the load carrying capacity of the column? Boom. Load carrying capacity of the column. Is it clear? Okay. Now I will answer Usman's question. This is how you will do. It's very easy. In exam, the question appears. Don't worry, you have identified that it belongs to the fixed case. Number one, write the formula. And even if you could not understand the bits before this, even if you focus right now, trust me, you will crack the problem. Number one, what is the Euler formula? Sigma critical is equal to pi square E over LE over R square. This is the first form of Euler formula. There is another form as well, and I will write both of them. P critical is equal to pi square E I over LE square. Done? Easy? Good. Happy? Very quickly you will get confused now.
This formula cannot be totally seen on screen.
Oh, okay. Thanks for pointing out. Okay, I just realized it. Okay, what should I do then? First of all, I will recite it for you. This is pi square. This is E, and then I added I. Okay, let me write it again. Oh, come on. I over. Okay, so let me remove that part. GG.
Should we, which are
right. So you suddenly have brought yourself in a very uncomfortable situation. Which are you? In fact, you will answer this question yourself.
Can we just take the square root of both of them?
No. That will be a big mistake. I will explain why. But before I do that, I will write one more step. Use the formula 1. You can use both of them, but second one will be useless for you right now. So what is the value of stress that you will use? Usman asked me. Go for 200 right now. 200 is a fine value between 200 and 250. Go for proportional if I do not give you anything else. If I only give you yield stress, then in exam, you have to use the yield stress value. So 200 into 10 power 6, I will answer Ahmed's question. 200 into 10%, and also the question where he asked what will be happen here. I will answer that. Pascals is equal to, okay, pi square E, ठीक हो गया, 200 into 10 power 9, okay, I, pi square E divided by, here comes the question, LE over R, right? Okay, LE over R. Very good. But what will I write here in the bottom? LIMITING limiting. But now I will answer Ahmed's question, and this is very important. What will be R if I have to ask you? This R will be, but RX or RY?
RX.
RY. Why? Because if I give you a situation where I have a steel ruler, forget about everything else, steel ruler. This is a fixed case, but let me consider the steel ruler case. I hold it from the bottom, fixed from here, and the steel ruler is free from the top. Oh, for sure, it is free, right? Now, if I have to apply a load and it has to buckle, in which axis will it buckle? Will it buckle tin or will it buckle tin? The answer to this question will be, you will definitely say it will buckle where the moment of inertia is less, where it is easier to buckle, in simple English. So remember that when you have lower moment of inertia, the object will buckle there, not where the moment of inertia is higher. You're getting my point. The ruler is weaker. You get my point.
So,
got my
for
point.
example, if you buckle like this, not buckle like this.
For sure.
So
Therefore,
if it were to the opposite, if the RY would be the 180 and RX were to be 30.
Then I will take RX.
Okay.
Then I will take RX.
Small.
I will take the smaller one. Ghazal, it is clear. So go for the small value. All the conditions are same, na? So if it has to buckle, what I'm saying is, consider a steel ruler in your mind. I have a steel ruler. I hold it from the bottom. So that's a fixed from the bottom. But steel ruler is free from this end. That's fine. Now it is free. I'm putting a load. More. It will buckle, right? It can buckle tin, or it can buckle tin like that. Between the two cases, if it has to buckle, you will answer me that it will buckle where it is weaker or thin or has a lower moment of inertia. I'm sorry, not thin, lower moment of inertia. So you will have to find in an exam the moment of inertia about both the axes, where it has lower moment of inertia or lower radius of gyration. I will repeat again, where it has lower moment of inertia or lower radius of gyration, because I is equal to AR square. So low value you go for. Done. Let me finish this problem, then we will go for a break. Just bear with me. It's fine, right? Everything is okay. Okay, thanks for hanging in there with me, by the way.
So a question. Do we need to use a form meter? And this information.
Hanji, so what?
Does the 4 millimeter information is
4 meter?
4 meter information is valuable or not?
It is valuable, but the use has not started yet. Now it will start. So the 4 meter is the total length. Now I will go here. Give me the value of LE over R limiting.
99.
Limiting or critical, but I prefer the word limiting. One of the students said it is 99 point. Okay, I will take it as 99. Come on, it's decimals for now. So, okay, good. Now give me the most important question. LE over R bracket actual. This is what is very important. Give me LE over R actual. Now, again, go back.
6.7.
Very good. He already found it, but I think I have to explain this. Okay, how did he do it? I will explain. You go back. So in an exam, you will have 4 cases. Identify the case. Which one is this case? 4. Go to the case 4. What is the effective length that is given to you in case 4? 0.5 L. Huh? What is the value of L? No, 4. The total length is 4. So the effective length will be 0.5 multiplied by 4. I will again repeat that the total length is 4. I never said that this is 4. The whole thing is 4. Please remember, I will write it again. Students are getting confused. Okay. Okay, so 0.5 multiplied by L for the case 4 divided by. Hanji, sorry.
We will use all
Give me 1 second. Yeah, R value is R equal to RY. And what was RY? 30 by 1000. Thank you. So let me write R equal to, again, but R, oh, come on, we have to go for a smaller value. There is no debate. What is the length? Total length? 4. Give me the value now. Boom. I think you already gave me. I appreciate it. So I will write LE over R. Actual is 67. Now I remember. Before coming to class, I thought that I will change this problem. After finishing the problem, I remembered that I forgot to do that. Okay, now the problem is we will not be able to apply Euler's formula. Anyways, I will change the question again. So it comes out to be 67. Now answer this question. Are we allowed to use Euler's formula or not? LE over R critical, LE over R actual turns out to be smaller than LE over R limiting. Okay, now I remember what I decided before coming to class. Anyways, pretty sad that I forgot. Here I wrote LE over R actual should be greater than the limiting value, but I am getting LE over R actual. Not allowed to use Euler formula it will either fail under yielding or it might fail under a combination of two. Now you can start arguing, but come on, 67 is way less than 97. I don't know. It is still a possibility. We have to double check. Pretty sad that I couldn't change the form. So what I can do is in 5 minutes on the next slide, I can change the problem and we will do it again. Do you want a break or should I continue? Okay. We will go for a break 100%. But before you go on a break, so far so good.
Yes.
So after you come to the class, what I will do is I will change this problem for my own benefit. And how would I do that? Very easily. I will create another problem, copy paste everything here. I will say that now the total rod is 8 meters. Just by looking, I know that then it will definitely fail under buckling. You will go through the same process because in an exam setting, you have to identify whether you can use Euler's formula or not. We have 11:35 right now. Do you want a 10-minute break?
Yes.
You have a 10-minute break. It's pretty sad that I forgot that I had to change the question. Before I came to the class, I knew I will change the question. Yes, please.
So for the RY value, we are not using RY value in the limiting part. We are using in actual part, right? The RY value.
Even if you want to use it, you can. Even here, if you want to use, let me answer Mitch's question and your question. Yeah, you can use RY here if you want, but right now I'm not using it. I just found the LE over R. So look, you can still, right? You can compare the effective lengths. I am comparing the LE over R.
Yeah, can I ask you a question?
Let me answer Mitch's question first. Yeah, then I will answer. Mitch, are you listening? Right? I can. Okay, I can answer your question. Mitch, the answer to this question right now, what happened is that I understand your question. The problem is that if I start going for the actual answers of this question, it will take us to a different route. So I will have to use one more formula, Rankin-Gordon. I'm not using it. So what I am writing here is that if this has to fail, it will not fail under pure buckling. And I will put a steric here. And if I have time, I will come back and I will come up with the actual answers. I will leave a couple of slides and I will start a new problem in which actually the object can fail under buckling. Mirch, was I able to answer this? Because I will have to use Rankin-Gordon and other technique, and it will take me to a different direction, which I want. Yes, please. Sorry. Now you can, of course.
I cannot understand the red part.
Thank you so much, everyone. Now let me try to change the problem again. So very unfortunate that I have to do this problem because I initially forgot. Anyways, so now I will change the problem very quickly. Same problem. But L is equal to, let's say, 8 meters, correct? Now, what is Rx? It is equal to 180. Ry, it is equal to 30. Okay, what is LE over R limiting? It does not change, right? You agree with me? Good, very nice. Like Usman, so I am doing the same problem, but this time length is 8 meters. So LE over R limiting One of the students told me it doesn't change. So value was 99. 99. Okay. Now I will try to answer Mid's question. LE over R actual is equal to so it was 8 multiplied by 0.5 meter divided by R equal to RY. How many students agree? So what is the answer? 123, right? 134. I appreciate it. Now when your LE over R has come out to be like this, big question. LE over R actual is greater than LE over R limiting. So this means it will fail under buckling, or a better English is we are allowed to use the Euler's formula. Nice.
Can I ask something?
Yes, please. Why not?
What if two situations will be equal to each other?
Yeah.
Actual is equal to-
Not allowed to use Euler's formula.
No.
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 But again,
Must be bigger than, greater than.
definitely.
Okay.
Yeah, again, I doubt that I would really want to. Nothing. Okay, so fail under buckling. Now, why don't you all help me? Did I answer Mitch? So, Mitch, a quick comment. Mitch, right now I will be solving the values because now I will try to answer your question. Then what are the answers? Now at least I can use Euler's formula. So my first question to you is, what will be the, let's go back. What was the question? Load carrying capacity of column. So give me the load carrying capacity. Any student? So it will be P critical is equal to pi square EI over LE square, and another formula was pi square E divided by LE over R square. So I think we can use the first formula. I don't know, it depends on you. Both of them are Euler's formula, but I will use the first one. So now give me the values. 124 kilonewton, 300 kilonewton, 329. Okay, again, I don't know the values, but I will believe what you just said. Pi square, the E value was given to me as
200 gigapascals.
Sure. Okay, 200 gigapascals. 200 into 10 power 9 kilo mega giga. Yeah, 10 power 9 pascals. Wow. We have value of I, which I have to go for IY, right? So what was the value of IY? I don't know. IY was 834 into 10 power 4. 834 into 10 power 834 into 10 power 4 into 1 by 1000 power 4. You did that right, Ahmed?
I do the other one.
Okay.
The E pi square over LE over R.
But we should get the same answers anyways. So P critical is equal to, okay, divided by LE, effective length is 0.5 multiplied by 8 meter. And just to be clear, Ahmed used this formula. So let me just explain the formula that he used. He used the formula pi square E over, he said I is equal to AR square and took the RY in the denominator. I think this is what you did, right? So both of them will give us an answer of 324 kilonewton. That's big value, by the way. But anyways, the RX is also 180 millimeter. You can just imagine 180 millimeter. That's 180 millimeter for RX is a good value.
We convert I
I selected I.
is meter by 4. It's true. Meter by 4.
The moment of inertia is BH cubed by 12, so it has meter power 4. So I had millimeter power 4. So I divided that with 1000 power 4 to convert the millimeter power 4 to meter power 4. So, Ghazal, are you with us? I changed the problem when the break ended. So what I did is I said the same problem, but this time with the length equal to 8 meter. Copy paste same problem. RX same, RY same, but the length is different. Would the limiting value change? No, the limiting value cannot change. It depends on, you remember, LE over R, nothing changes. I got the same 99, but now LE over R actual has instead of 4 or 8 here. Tahsin Chan, are you with me? And then LE over R actual, thank God, comes out to be greater than the limiting value. So I said now if it fails, has to fail by buckling, and I am allowed to use the Euler's formula. I wrote the two formulas, both of them are Euler's formula. I went for this expression. One of the students said, I am preferring to use pi square E A over LE over R square. He used R equal to RY. I used IYY. Both of us got 324 kilonewton. Should I continue now? Mirich, let me ask Mirch and Hussain as well, and Hasung and Muhammad Al Khatabi and Aisha. Everything is fine. Should I continue? I will answer Mehmet's question now. So, Mirich, now we have an actual answer. Okay. Before I answer Mehmet's question, we can put it like this. You can also find the critical stress, for example, for this buckling, right? So you can divide this by area. Can you do it yourself? I think you have to divide this by area. So you will also get sigma CR if you want. Okay.
Hojam?
Yes.
I think I'm getting a different value. I'm not getting 324 kilonewtons. I'm getting 411 kilonewtons. Okay. I don't know why.
Okay. Could be 411. Unfortunately, I don't have the answer to this. So I can write 411 if you want. I honestly, I'm not.
No, I just wanted to,
It's okay. It's okay.
Sorry. Okay.
No worries. No worries. Hocham, there is LE square. Why we had 0.5 into 8? What happened? Oh, did I make a mistake? Sorry. So there is a scare. Oh, I think I made a mistake. Okay, do it again then. Probably. Yeah, I'm sorry. I made a mistake. Who was that? Mirich. Mirich, I'm sorry. It was a mistake from my end. Sorry. I forgot the square. But you are sure about the... Can you also double check 324? Yeah. Please. Now that we are writing, let's write the right answers. So you are with us, right, Ahmed? Everything is fine? My point is, now I took the length of 8 meters. So I changed the problem. I changed the length. When I change the length, everything else remains the same. But my LE over R actual now comes out to be 134. It is definitely greater than 99. It has to fail under buckling. I am allowed to use the Euler's expression. Now let me question. I'm sorry. Yes, please.
I have a question about the moment of inertia XX and moment of inertia Y.
Yeah, we selected YY because moment of inertia YY was less
I
than.
understand that part, but did the question give these values or
I
define?
I gave for this for this particular problem, I just give it. But in general, I think you already know how to find it. Okay. Okay, whatever. I think everyone got it.
Hocam, I think the answer is wrong.
What is the answer?
102,8906.25.
Okay.
Yes,
you-
yes, Hocam, I agree. It's around 1,000 kilonewtons. Very close
Okay,
to
hang
1,000
on.
kilonewtons.
Okay. So give me the value 1000.
1,029.
You know what? I have to proceed to the next problem. Okay, on that note, everyone is happy. Life is good. Okay. I tried to bring some printed copies for you for a couple of solved examples. Unfortunately, I could not. The printer did not work. So what I can do is, what happened? So next time I will bring those printed copies, or I can also show you on O2 class. Now, just to give you a perspective, although it's too early, I hope you don't get confused. What happens is, should I explain right now? How should I? Probably I will do one more problem. Let's keep things simple. Then I will explain concepts in a different class. I think it's not the right time. Okay, do one more problem for me, gentlemen. I think life is beautiful for us right now. So you have to do this problem yourself, but I really want to make sure that I'm not giving you some wrong problem. So let me create a problem for you very quickly. Let me go for fixed free. For my fixed case, the critical effective length was 0.5 L, and here the effective length is 2 L. So for lower value, I have a feeling that this object has the tendency to buckle. Okay. So you know what? Let's do the fixed free case. Now I will create the same problem. So I'm coming to your desks, same problem. Same problem. So let's do a fixed free case. Do you want me to come up with a new problem entirely, or? Okay, let me, in fact, let me create a new problem for you. I have a bad feeling that I don't want students to get confused. So forget about the same problem. It is worth some effort. So I will create an entirely new problem for you. If the values come out to be funny, then I don't know. Then I will put, this is definitely free, right? Huh? Okay. The problem says that I have a rectangular section. How should I make it? 10. So it will be like this. Okay. And I'm looking at like this. Okay. The question says that this is, let's make it very, very small so it easily buckles. 10, let's make it 10 millimeter by 20, 5 millimeter by 10 millimeter. It definitely will buckle very quickly. So let's make it as 5 millimeter by 10 millimeter. I'm doing my best so that it buckles easily. If it doesn't, then it's just bad luck. Now let's say the length is 4 meter. Now, first thing first, you have to tell me what was the elastic modulus in the previous problem? 200 gigapascals, right? Okay. What was the proportional limit?
200 megapascals.
And what was the? Oh, come on. This problem, I hope works. If it doesn't, then I don't know. Life is brutal then. Okay. Do it. and the total length is 4 meters, right? The first thing that you have to give me is, this is XX and this is YY. This is YY. Be careful. This is YY. And this is XX. Give me the value of and by the way, this is solid rod, right? IXX or IX, whatever you call it. Then give me IYY. Then give me RX. Then give me RY. Then give me area. I hope this problem works out. Teshin Chan, you can also try. So do the IXX is equal to BH2 by 12. The total height is 10 millimeter. I mean, that is 5 millimeter. The complete thing. Hanji.
For IXX, it will be 4.2 times 10 to the power minus 10.
4.2 into 10 power.
Minus
Okay.
10.
Yeah,
I
we
know.
not put it on the direction.
And don't forget, George.
You did a 5 multiplied by 10 power 3 divided by 12, right?
Yeah.
Okay. What about IYY?
12. 5 cube 10. Multiply.
Yeah, but you have to give me by calculator because that I already know.
John, 1.7.
1 point. 17 or 70. 1 point.
John, I found 1.04 times 10 to the power minus 10 meter.
Could you please write how could we calculate BH cube by 12? Okay. Mitch is asking the question, so I will answer Mitch's question first. IXX is equal to B multiplied by H cube divided by 12. And the second question of Mitch is how to find IYY. That is B H cube. Mitch, did I did answer the question, right? Okay, thank you. What is IYY? 1 point?
0.4 times 10 to the power
Yes.
minus
10 power minus 10? 10?
Yes.
10? Achha, okay. Okay. Give me the value of Rx and Ry. Chat message from Mitch. Yes. Okay. Rx is equal to, so I is equal to, so just to answer everyone's question, this is a Rx square. Agreed?
Yes.
Give me Rx. Teshin Chan will give me the Rx value.
Hocam Ali 50 millimeter square.
Hanji?
Ali is 50 millimeter square, right?
Yeah. Oh,
2.88.
15, sorry,
2.88.
2.88. And similarly, IYY is ARY square. Usman, this is millimeter, right?
Yeah, hocam.
Okay. And then RY in millimeter is,
1.4.
by the way, just be careful because your I is in meter. then area is, so be careful if you are giving me the answers in millimeter or meter, just decide. This is millimeter and Ry is 1.44.
Why it's exactly not?
I have no idea.
Is it because the dimensions of the rectangle are half of each other?
Possibly,
Could be
but
related?
possibly because right now from like this, I hard for me to comment. But possibly one of the reasons. BH cube by 12, 1 is power 3. One is power 3, one is power 1, then area has power 2, so eventually came out to be half. So you also have this 1.44 millimeter and 2.88 millimeter.
For RX, I found that
But my point is just double check that all of you are using the same units. If that was converted into meter, then area should be converted into meter, and then you should convert
yes.
everything into millimeters. So, okay, as long as everyone says that they are fine. Done. Now, quick question. What is LE over R limiting value?
99.
Yeah, but you know what? I really would want to repeat those steps because I'm scared that everyone will forget. So I will say sigma critical is equal to pi square E over. I don't want to just leave it for all the problems because everyone will start struggling in their exams. Sigma critical is equal to pi square E. Okay. Forgot. One minute. Come on.
Hocam, this is the fixed free case, right?
Absolutely. Absolutely.
Okay.
Pi square E I. Come on, why I keep forgetting? Pi square E over LE over R square. I don't know why I keep forgetting. Over LE over R square. Gentlemen, why don't you double check? You still are getting, I think everyone will say the same thing. LIM, they are still getting the same thing, right? Oh, come on. So Ghazal, I repeated everything. So just so that everyone is 99, right? Right, Ghazal, I repeated.
So for critical, we will use the sigma PL, right?
Yeah. I just used it. In an exam, if I don't give you sigma PL and I give you yield stress, then you can use yield stress. Okay, now the moment of truth. We have some students who are planning to help us. What is LE over R actual?
55.5.
Oh, come on. Seriously? After all this hard work again? Seriously? Really? 55? Oh, come on. How can I do it? Anyways.
So, 2 multiplied by 4.
Huh?
Divided by.
Okay, 1 minute. What was the total length I gave you? 4?
It's not 10.
Huh? Okay, but hang on. But let me finish this. 4 multiplied by... No. What was the case?
Fixed free.
In fixed free, it is 2L. So Hussain and Mirch and Hasung and Aisha,
Yes,
everyone is with us. So fixed free case, L effective will be 2 multiplied by L. So 2 multiplied by L means 2 multiplied by 4. Oh, come on. I'm still not believing. 2 multiplied by 4 divided by. Okay, what is the value of R? Should we select Ry or Rx? Low value of moment of inertia or low value of R. So it is 1.44. Oh, come on. Seriously, 10 power minus 3. Can anyone double check with calculator? Is it actually coming out to be 55? Okay. Come on. I just don't believe that after all the hard work.
Hocam, it says 5,555.
That's why I'm saying 5,000.
Yes.
Okay.
Yeah, 5,000, yeah.
5,555.
55.
Yeah, like just now it makes sense because come on, it is how much? 10 millimeter and 5 millimeter. Like, come on, 10 millimeter is less than half inch. How little of a cross section do you want me to select? And even with 4 meter, it was coming out to be 55. That's why I was a little rattled. That's too big, by the way. Yeah.
Using the R value, you're looking at the moment of inertia. For example, if the Ix is much lower than the Iy value, you will use the Rx, right?
Ix is less than.
Less than Iy value.
Then Ix is less than R. Yeah.
So we will use the Rx.
So let me repeat this question. One of the students have a question. What if Rx was less than Ry, or what if Ix was less than Iy? Well, if that is less than, then for sure you would have selected Rx. So gentlemen, should we continue? Life is good. 5,555. That is big, by the way. So the point is that this is definitely greater than 99. Hanji? Yes,
Fail.
sorry.
Can you say fail on the buckling?
Of course, 100%. LE over R actual is greater than LE over R limiting. Done? Why? Because 5,555 is greater than 99. Now give me the final answers. So let's go back to Euler's formula. P critical is equal to pi square E A over LE over R square. So pi square E A over LE over R square. So I think Ghazal can also help us. This LE over R, Ahmad Mehmed, Ghazal, Tobash, Usman Bahadur, Tahsin Chan. This LE over R will be actual, right? Something that you have to remember. And what about the R value? That is Ry, if I remember, because that was less than. So now I will have pi square multiplied by 200 into 10 power 9 pascals multiplied by 50. 5 into 10, 50 into 10 power minus 6, I think. You have to double check. I don't remember. Divided by I think P critical will come out to be a very low value, but anyways, give me the P critical. That's not good. It will be coming. I hope it is not in newtons. Well, that what happens when I come up with a problem myself. Because I wanted to make sure that we have a good problem. Seriously? No, come on. It should be a little less. So less than a Newton?
3
times
meters.
10 to the power of minus 4.
10 power minus 4, and you found
3.2.
3.2 Newton. That's nothing actually. It will just, it is ready to buckle. Huh? No. Really? No. No. What?
Why did I find the help of this value?
Again, just tell you y square into 210 power 9. 50 into 10 power minus 6. There is no square. So in 50 into 10 power minus 6, there is no square. Okay. No, it will not fail under the it will not buckle under the weight. That's why I got this. No, we cannot say that. Anyways, 4 meter is a big length. Come on, and for such a thin section, just imagine such a thin rod, and you're just it's gonna it will fail under buckling. It will not only buckle, it will fail under buckling at 3.2 Newton. So remember, there is a difference between just buckling and failing under buckling. It will fail under buckle. That's not good.
Hocam, so below this force, it will only buckle. And if we exceed this force, it will fail under buckling, like you said, right?
P critical. So you have to understand. Okay, good question. These critical values that you are finding, so you have to understand like this. I will repeat. This is the difference between stable and unstable. Look, I have a rod. I keep on applying load. Tin. I keep on applying load. It does tin. I remove the load. It comes back. Then I apply greater load. Tin. Fine. I remove the load. It comes back. There is that certain value of load. I put it on this. It goes like tin. But the moment I remove the load, it doesn't want to come back. That's when the structure has failed under buckling, when the critical load has exceeded, when that's what is failure for us. Over. System is unstable. So right at that threshold where you're sitting at the limiting, where your load is right at that boundary of stable and unstable, you call that load as the critical load. That you apply that critical load, the system is just sitting there to just fail. If you increase the load even by 1 millinewton, the system will fail under buckling. So the moment you remove the load at 3.2 Newton or 3.199 Newton, the system will come back. But you do not want to go to 3.2 Newton, which is the critical load, because you are right at the verge of failure, or system getting into unstable, or system getting into permanent failure, if you want to call it.
Got it, Hocam. Thank you.
Okay. Okay, if I have to do this problem one more time, I will definitely decrease the length by 10-15 times. But anyways, it's in the past. I cannot change something that has happened in the past. So example 3. Do this problem. The question says that I have now Gigi. Yes. Please.
If we were to take an extremely thin but a very heavy rod, so the material is very dense, and magically put it on the ground at exactly 90 degrees. There is no wind and planting, so it will never gonna fall. Let's assume it. Could it actually like buckle and destroy itself under its own weight?
No. No, because no. You have to understand that first of all, you have to give it an initial condition, right? For example, every time I'm telling you it will buckle, it is buckling, it is doing 10, then you apply more load, it is doing 10, but none of you actually have asked me whether it will do like 10 to the left or it will do 10 to the right. None of us you have asked me this question, because that is dependent on the initial condition. If you give a very little initial condition, then it might, the initial condition might be pushing this towards left, so it will do a 10 towards left. So first of all, there will definitely have to be an initial condition which will be present. Second, this buckling under its own load. No, we have to put an external P load, because technically its own weight is going right through it. So would it fail under its own? No. As far as the question that you asked, that if we have a really heavy material, I would say high elastic modulus or greater value of proportional limit. Well, that elastic modulus and proportional limit will come into those critical fellow that we calculate, and the LE or R actual will come into the actual fellow. Extremely thin. How much thin? Under its own weight, I don't want to endorse this idea. Actually, you have to put an external load. At least this is what we have been doing right now. Even if you remember, just to be clear what the value of P is, it is a good question. You see, in all of these cases, you see that P, we are putting an external load. And another incredible thing, in all the derivation, what you have to realize is that No, the weight factor we never included, so don't worry about that. Okay. Anyways, good question. And on that note, let me put a nice, beautiful hinge to it. I don't think I will be able to do this problem. So why don't you take it as a take-home task? So this is nice, beautiful pin joint. Okay. The good news is that this problem is already, I have the values, so we are not gonna come up with 3 Newton answer. Okay, now I will put a little thickness to it. The first question that our students want to answer to me is which case does this belong? Hinge, right? Now, there are students who are asking, what is the meaning of this big fellow? Yeah, because I want some place where I can put the load, right? Are you getting my point, everyone? I need some place where I can put the load, so that's fine. Now, the question says that this object, let's see if any student has any questions. The cross section is like this. Yeah, it's a circular tubular section. The inner dia is 30 millimeter and the outer dia is 40 millimeter. Length is 2.5 meter. Sigma yield is 300 megapascals. You see, Usman, and here comes the answer to your question. I did not give you the proportional limit. So you don't have any choice in the exam then to use the yield value. Okay. So elastic modulus is 2 into 10 power 5 megapascals. Give me the value of critical load. Is this clear to Hussain and Mirj? And we have Aisha and, okay, we have 3 students with us. Critical load.
Hocam,
Anji.
how come yield strengths could be bigger than the elasticity modulus?
Well, it's not bigger. 2 into 10 power 5 is greater than
Oh,
300.
yeah.
Okay, don't worry. And now, this is your take-home task, but let me be clear on this. What is the value of Ixx? It will be equal to Iyy. Let me give you the formula. Pi divided by 64 into 40 power 4 minus 30 power 4. Okay, hang on. There are students who are getting confused, so I will help them. It is pi by 4 into 20 power 4. Oh, come on. 15 power 4. Is it fine?
It's same formula for J, right? In portion.
No.
J will be.
Hocam, I don't think the second one is correct. I'm not really sure, but
Second one is wrong.
I don't know. We used to always use the first one, pi over 64 diameter to the power of 4. That's what we used.
Okay, gentlemen, I think both of them are correct, but you can use a calculator.
I don't know about the second one, so I'm not really sure.
I am 100% sure about the second one. It's the same thing,
Okay.
right? Usman, the torsion value, the torsion formula used to use a J or IP, polar moment of inertia. IP or J. It is different than this I. This is polar moment of inertia of an object, the ability to resist this. This is polar moment of inertia. Like the ability, I'm sorry, the ability of object to resist this. But if you do like pull like this, then you will have Ixx or Iyy. These are different films. Just to clear further, the J value would have a pi by 32 here. Usman, the J value will have, or IP value will have a pi by 32 here. Whereas Ix or Iy have a pi by 64 here. So if I had to use J value, I will put a pi by 32 here. In your notes, hang on. In your notes, you have written a pi by 2 here. Pi by 2 C power 4 in your notes. Here I have a pi by 4. Okay. Class is over, by the way. Let me just finish this, or probably, I don't know, we can do it next time if you want. Okay, in my notes, this value comes out to be 8.59. The class is over, by the way. I know you have classes. 10 power 4. Yeah, exactly. Exactly. And similarly, I have I is equal to, so the class is over. Have a good day, everyone. Rxx is equal to Ry is equal to square root of I by A, right? Because I think I is equal to AR square. Okay, good. So that value comes out to be 12.5 millimeter. Now, before all of you are leave the class, I have just one last question for you. Will it buckle? Will it buckle like tin, or will it buckle like? Oh, hang on. Yeah, that will really confuse you. So I can ask you that question. But the point is, since Rx is equal to Ryy, you just proceed with the, and we can finish this topic next time, and I can start a new topic next time. So XX, and this is. So just finish this problem. So will you be able to finish this yourself, by the way? Sure. Okay. Now I want to add one more comment. Probably you will be able to understand this, so I will make an effort. Just remember one thing. I will be giving you 2 examples. I will posting them on O2 class. Those will really challenge you a little bit. How? If I ask you that this object has pin joint there and pin joint here, it can buckle ting, or depending on the initial, the way you have put a force, it might buckle ting. I have a next question for you. If I ask you, can it buckle ting, like in that plane, can it buckle or not? So you have to be very careful. The revolute or hinge prevents, not prevents, is coming to the picture in this plane. So there is a pin joint, tin, so it's a pin case. It's a hinge case. Life is beautiful. But in that plane, it's a fixed case. I'm not sure how he figured out so quickly. It's a fixed case. So for example, if I had to look from here and I ask you, is there some way this can buckle in this plane? Those hinges will now try to avoid that by acting as fixed. So as of now, in this problem, you have to take it as hinge and finish the problem. But in the examples I will be posting, it will really challenge you. It will push you to your limits. You have to understand that if the problem is in such a way, you have to imagine, what if it has a tendency to buckle in this plane? The same hinges will act as fixed supports. I wish you a good day. Bye-bye.
You mean buckle like this, right?
As of now, it is just buckling in a pin in this plane, left or right, I don't know.
Okay.
Thank you. Have a good day. Bye-bye. No, I haven't even started yet. I have to finish the 206 in a couple of days, then I will start the 208. Just bear with me. Thanks. Bye-bye.
So, to draw actual 6 and to draw exam results haven't been totally.
No, I am still working on it, because the 206, especially in terms of grading, it is taking a lot of time because there are so many steps.
And there are diagrams, formulas.
That's why I have to go every step, and each paper takes a lot of time. For Ghazal, I think I graded the exam paper, but anyways, in a couple of days you can see.
Okay.
See you. Thank you, everyone. Have a good day. How pi by 32? There's a question from Mirch. I will answer. Mirch, what is your question? Can you unmute the mic?
Can you hear hocam?
Yeah, Mirch, the answer to your question is that these are diameters and the C value is radius. So if this is a dia equal to 2R. So 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 4s are 64. So that's why if you, instead of using a dia, start using the radius, then 2 power 4 will cancel this and pi by 4. So both this formula and this formula will give you 8.59 into 10 power 4. This is the answer to your question.
Yeah, hocam.
Yeah, the right one. Oh, wow.
Can you put it into square?
Yeah, so not the answer. So this is the moment of inertia answer. This is not the answer of the problem.
Ah,
I am giving you a take-home task, but next time I can at least solve this for you if you want.
no,
Don't worry.
okay.
These are just the moment of inertia. Marriage, is this clear?
Hocam, yeah, no, it's okay. I just wondered why it's not 32, why 64?
One moment. It is pi by 64. It is not pi by 32 because you remember that shear stress is equal to TR over IP or TR over J, the polar moment of inertia, IP or J. Remember that?
Yes, hocam.
The J value is pi by 32 into D power 4 or pi by 32 into D2 power 4 minus D1 power, minus D1 power 4. Pi by 32 comes in the polar moment of inertia. Similarly, if you want to write the polar moment of inertia formula in the form of radii, it is pi by 2 into C power 4, that is radius power 4, or for hollow pi by 2 into R2 power 4 minus R1 power 4 or R naught power 4 minus Ri power. But when it comes to simple moment of inertia, that is 50% of that value. So it's not pi by 32 anymore. It is pi by 64 into D power 4 or D2 power 4 minus D1 power 4 in terms of hollow. And when you write the same formula in the form of radius, you can just see on your screens right now, it is pi by 4 into R2 power 4 minus R1 power 4. Again, this is for simple moment of inertia. For polar moment of inertia, it will become pi by 2 here. Did I answer your question?
Yes, hocam, yes.
An object, Mirich, an object, just imagine like this, that you are twisting has an ability to resist that. That is polar moment of inertia. When the object, let's say, is going through bending, that is simple moment of inertia. When the object is buckling, that is simple moment of inertia. I. Thank you.
Thanks, hocam.
That's why stress is equal to my over I has simple I, but shear stress is equal to TR over IP has polar moment of inertia, or J as you call it. Okay, thank you. Have a good day. Bye-bye. Bye-bye.